Hi everyone, my name is Sahish Gupta and I'm currently working as a software engineer at Demandes. So I am part of core team there. I have more than 5 years of experience in building software. So I am part of a team which owns most of the APIs and MCP server at Demandes. So this was about me, and from today onwards I am setting a goal for myself to put a new video out every week for the next 3 months. So my goal will be to have a conversation about AI and AI systems. So let's see if I am able to achieve my goal or not. Okay. So my agenda for today is to talk about retrieval in RAG systems. So as we know that LLMs only have understanding about the data on which it was trained on, but all the information that you have with yourself, right, your knowledge base or the Google Drives documents or whatever information you have, it does not have understanding on top of that. So when you ask some question related to your knowledge base, so how can you provide this information to LLM, right? So you can't paste everything in the LLM because of the context limit restrictions that we have, as well as when we paste everything, it will cost us more, and the quality of results will also go down. So it's very important to first fetch very relevant documents ourselves and then provide that information to the LLM. So for this purpose we have some algorithms, like first one is BM25 or keyword search algorithm. So this algorithm is like 20 years old, 40 years old, and it relies on few things like how many times a particular keyword is occurring in a document, how many times the document is occurring in different documents, right? So it depends on IDF, which is basically log of total documents and documents containing the term. So if the document, if every document is containing that term, then this value will become 1 and log of 1 is 0. So that word is no longer relevant, right? All the documents score remains same. Then there is something known as length penalty. Suppose the document size is very large, so we penalize the score for that. As we can see here, suppose the current score is 2.27 here. So if I decrease this value, so this score will change, right? So it is used to penalize the long documents, and there is something known as term saturation K1 score. So what it does is, let's say there is a word deluxe in a document, right? So when this keyword occurs first time, then the relevance score is changed by higher proportion. Then the word is occurring, suppose 10th time, so the 10th time relevance is reduced as comparison to the second time or the third time. So each time we will be adding the relevance score by very few points, right? So this is used to control the relevance score. And we have some examples, right? So we have some documents in our system and we are trying to search software architecture, so it is able to find 4 documents and 2 of them are actually correct and 2 of them are not. So here it is able to find this exception message. So the problem with this approach is that we are doing keyword search, but it is not finding out the meaning behind that word, right? the word is car, but in the document we have written automobile. So the meaning is same, but we will not be able to provide the result correctly, right? Because it is not checking the meaning behind things. The second approach is semantic search, where we turn each document into a vector of numbers, so that similar vectors will be close to each other in the vector space. And the query we receive also, we convert that to vector, and we do cosine similarity to find out to which document this query belongs to, right? But the problem with semantic search is that suppose there are some error message, right, or some versioning numbers or product SKUs, so all these gets blurred out when you create vectors or you try to find out the meaning behind it. So in some scenarios it works, but in some other scenarios semantic search also doesn't work. So we can compare that. Suppose we are searching this error message, right? So keyword only will be able to find the correct documents, but semantic search will struggle to find the correct documents here. So there is a need for like combining the two approaches here. So what we do is, like, we combine the score received from keyword search as well as from cosine similarity. So we uses one methodology to combine those scores, fuse them together, and present the final result back to the customer, which is much more reliable as comparison to any of these two ways. Then we will talk about chunking, where retrieval is quietly won or lost. So when we have a document in which multiple lines are there, so we need to convert them into vectors, right? So if we start creating a new vector for each line, so this will be more precise, but the downside is that we will create too many vectors, and it will be consuming a lot of context memory, and it will be creating issues for us. So when we try to increase the chunk size, then also there will be an issue, because there might be one statement which is very relevant, but it is surrounded by other noisy statements, so the overall score might be reduced because of that. So there is no right size as such for chunking, and there is also concept of overlap. So suppose here we have like this statement, service contracts continued to grow faster than hardware. So if I split here, right, and if I start the statement than hardware, then it loses its meaning, right? So what we do is we take some part of the previous chunk and add it to the next chunk as well, so that it retains some of the meaning, right? But still there can be scenarios where this approach can again still not work. Suppose we have created this chunk, right? It grew 3% quarter over quarter. So here there is no way for us to identify what it signifies, right? So there will be like problem for us to identify which are the right documents to retrieve. So what we do is we use some cheaper model to generate the context and add it to every chunk, right, before indexing into the vector database. So when we add the context, suppose we added this line, this fragment is from the Acme quarter 3 financial report, right? So as you can see, previously we were not able to fetch the right document. The right documents were at position 12th and 15th, but when we added this extra information, right, before indexing, we were able to get the right documents at the top, right? Then I also want to talk about like precision and recall. So precision is basically how many hits we got out of the total results we are fetching, right? And recall is basically how many hits we got out of the total records which were actually correct and were marked by humans, right? So when we increase the retrieval count, right, k retrieved documents, so we can see that precision goes down but recalls gets increased, right? So this happens because the chances of all the documents which are correct, uh, we are able to find them when we increase this size, but overall precision will go down. So we can also have this in mind once we are creating RAG systems, so that um, we can check, okay, what should be the ideal value for k. Sometimes it's the k which is affecting the precision and recall. So I think this is it from my side in this session. So I will see you in the next session. Goodbye.